Alright, how you guys doing today? This is Mr. Muscarella coming at you, and in this video lesson, we are going to take a look at solving trig equations, part 1, but examples 4 and 5. Now, one of the things we're going to do is we're going to solve problems algebraically, of course, but then we're going to show you how to verify them graphically, and I'm going to show you a little bit new feature called the table ask feature of your TI-84. So make sure you have your graphing calculator close by. Now, here's our first problem. So our first one, we're going to solve the equation tangent of 2 theta equals -1 in the interval 0 to 2 pi. So that means once around the unit circle. Now as I start to think about this, one of the things you want to do is think about on the unit circle, where is tangent -1? And tangent is going to be -1. And one of the things you can kind of think about is ASTC, where is tangent negative? So you know there's got to be a value here in quadrant 2 as well as down in quadrant number 4. So in quadrant number 2, that value is 3 pi over 4. That's where tangent is -1. And in quadrant number 4, it's at 7 pi over 4. Now, one of the things you want to notice about these two particular values is that they are pi apart. So if I were to travel from 3 pi over 4 all the way to 7 pi over 4, I would travel a distance of pi. So what that means I'm going to do, I'm going to take this inside piece right here, this angle, and I'm going to set 2 theta equal to 3 pi over 4 plus k pi. And then k is going to be any element in the set of integers, and that's represented by the z right here. Now, one of the things I want to do, though, is divide everything by 2, because I want to get theta by itself. So when I do that, I'll end up with theta equals 3 pi over 8 plus k pi over 2. Again, k is an element of the set of integers, or KEZ. Our textbook tends to use k, others might use n. It's just a general variable. But this piece right here, 3 pi over 8 plus k pi over 2, k is an element of the set of integers, this is what's called the general formula. So this is a general formula for any solution to this problem, tangent of 2 theta equals -1. But I only want to look at anything that's in the interval from 0 to 2 pi, because that's what my directions tell me. So what I'm going to do is I'm going to let k represent different values. But before I do that, one of the things I'm going to do is just get a common denominator here, because that'll make things a little bit easier for me. So I'm going to rewrite k pi over 2 as 4k pi over 8. Now when I do that, if I let k be 0, then that means I'm going to have 3 pi over 8 plus 4 times 0 pi over 8. Well, that part's going to give me 0. So that's going to return a value of just 3 pi over 8. Now if I let k equal 1, now what I'm going to have is 3 pi over 8 plus 4 times 1 pi, all of that over 8. When I combine everything and simplify it, I'm going to end up with 7 pi over 8. And I'm going to repeat this process until I get to something that's more than 2 pi. So if I let k be 2, I'm going to have 3 pi over 8 plus 4 times 2 pi over 8. 4 times 2 is 8 plus 3. I end up with 11 pi's over 8. When k is 3, this time we'll get 3 pi over 8 plus 4 times 3 pi over 8. When I'm all done, I end up with 15 pi over 8. Now if I let k be 4, that's definitely going to be more than 15 pi over 8, which would put me over 16 pi over 8. And 16 pi over 8, if I reduce that, that would just be 2 pi. So I don't even have to do k equals 4. So the solutions that I get algebraically for theta are going to be 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. So those are the 4 solutions that I come up with when I solve this problem algebraically. But what I want to do next is go ahead and verify my solutions graphically. So what I want you to do is go ahead and put tangent of 2 theta in y1 and put -1 in y2. So your calculator should look like this, your y equals screen. I'm going to make this a little bit bigger just so that you can see all of this. All right, so that's what your y equals screen should look like. Now again, just make sure that your calculator is in the correct mode. You should be in radian mode, not degree mode. So if you're in radian mode, you're good. If you're in degree mode, make sure that you change that. So now that you're in the right mode, let's go ahead and hit zoom, and then number 7, trig. Now this is our standard trig window, which goes from -2 pi to +2 pi along the x-axis. I don't want all of that, so I'm going to adjust my viewing window here, and I'm going to go from -pi/2 all the way to just 6.5. So go ahead and adjust your viewing window just so that it matches mine. When you're done, go ahead and hit graph. All right, now this is a little bit better. Now what I want to key on are these 1, 2, 3, 4 spots that the two graphs intersect. And so graphically it looks like I've got 4 intersections. Now how can I verify that those 4 spots are at 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8? Well, I'm glad you asked. What you're going to do, there's a couple different ways you could approach this. And in this video I'm going to show you the table ask feature. So what you're going to do is hit the second window button. And you're going to set your independent variable, this indPNT, you're going to set that over to ask. And then what you're going to do next is go ahead and hit second and then graph. Now if you have stuff in there, like I do right here, what you're going to do is just go ahead and hit the delete button for each one of the things that are in there. Now the values that I came up with are 3 pi over 8, so I'm going to go ahead and type that in. Now notice when I hit enter, the calculator changes that to a decimal of 1.1781. But what I really want to pay attention to here is that both the y1 and the y2 columns are -1. They agree, they're exact, they match. So that tells me that 3 pi over 8 is a solution. Graphically, that would be this very first spot right here on my graph. Now 7 pi over 8 would probably be this spot right here, so I'm going to go ahead and I'm going to verify that and type in 7 pi over 8. And again, my calculator helps me out and says, yeah, that is the correct solution. And if I did 11 pi over 8 and 15 pi over 8, I should get the same values. So as you can see from our table of values, 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8 are all values that are solutions for my equation tangent of 2 theta equals -1. So I found my solutions algebraically, but then I used my graphing calculator to help me verify these. Now let's go ahead and take a look at problem number 2. For this problem, we're going to solve the equation on the interval from 0 to 2 pi. Now with this one, again, we're going to ignore this angled part here in the middle. I just want to think about the word sine. Where is sine +1? And if I know my unit circle pretty well, I know that sine is 1 right up here at pi over 2. Now that's one solution right there. But if I wanted to go all the way around the unit circle, I'd have to travel a full 2 pi. So this time what I'm going to do is I'm going to take my angle, this 3 pi plus pi over 18, and I'm going to set that equal to pi over 2 plus 2k pi. And again, k is going to be an element of the set of integers. So I'm going after my general formula piece right here. And then to kind of help make this a little bit easier to work with, I'm going to get a common denominator here of 18. So this is going to make this pi over 18. It's going to stay the same, but then I'll have 9 pi over 18, and then plus 36k pi over 18. And you'll see why in a minute, because we're going to be moving some things around, and this will just kind of make it a little bit easier for us. Next, when I subtract pi over 18, so now I'm going to have 3 theta is going to equal 8 pi's over 18 plus my 36k pi over 18. And again, k is going to be in a set of integers. Now the last thing I'm going to do is go ahead and divide everything by 3. So when I do that and then I reduce, I end up with theta is going to be equal to 4 pi over 27 plus 2k pi over 3, where k is an element of the set of integers. That's going to be my general formula. But again, I want to go from 0 to 2 pi. So what I'm going to do here is get a common denominator of 27. So the first piece I'm not going to have to do anything with. That'll stay as 4 pi over 27. But then my second part, the 2k pi over 3, that's going to change to 18k pi over 27. And this is what's going to help me go ahead and figure out what my angles could possibly be. So what I'm going to do is go ahead and let k equal 0. And if k is 0, then theta is just going to be 4 pi over 27. If k is 1, now I'm going to have 4 pi over 27 plus 18 pi over 27, which if I add those two together, I just get 22 pi over 27. Now if k were 2, this time we'd have 40 pi over 27. Now if k were 3, I end up with a value of 58 pi over 27, which is more than 2 pi, because in terms of 27s, that'd be 54 pi over 27. So that's too big. So my only values that work, so theta is going to have a value of either 4 pi over 27, 22 pi over 27, and 40 pi over 27. So these are the three values that I get from 0 to 2 pi when I solve this problem algebraically. Now go ahead and verify this graphically, and then let's come back and check and see how you did. So hopefully you were able to verify that using your graphing calculator the same way we were here. Now a quick tip here, if you want to get to 3x plus the pi over 18, to get that pi over 18 to be a fraction, all you need to do is hit the alpha and then the y equals button. And that very first thing, n/d, that's numerator / denominator. So when you select that, that'll allow you to go ahead and enter something as a fraction, as you see here on the screen where it's pi over 18. Alright, that's it for this video. By now, you should know how to solve trig equations that are in the interval from 0 to 2 pi. Also, you should know how to determine the general formula for solutions to a trig equation. And in addition, you should know 2 different ways to verify your solutions using your graphing calculator. Alright, thanks for watching, you guys, and you have a great day. I'll catch up with you soon. Peace out.